Chapter 13.3, Completing the Square. First, let's review how you can use a square root to solve an equation. So for instance, A, we have x minus 2 squared equals 9. And in order to undo the square, we can take the square root of both sides. And when you take the square root of something that is squared, the square root and the square will cancel each other, leaving you with just x minus 2. And when you have the square root of 9, there are two answers. You've got positive 3 and negative 3 that come out. So we'll say plus or minus 3. And now we'll add 2 to both sides. And there are two answers. We have x equals, let's take the positive version, 3 plus 2, and we'll have x equals negative 3 plus 2. And so we'll have x equals 5, and we'll have x equals negative 1. Let's answer that in set notation. X equals the two answers, negative 1 and 5. And you could check your work there if you'd like. So put in negative 1 into the original. You'd have negative 1 minus 2 squared, which would be negative 3. And negative 3 times itself is 9. And if we'd put in 5, we would have ended up with 3 squared equals 9. Okay, let's try the same thing for B. Alright, with this one, let's see if we can rewrite both sides a little bit. Maybe the right side being a square, we could see if the left side's also a square. What's 4x and 3, 4x and 3? We would get the 16x and the 9, and we would get negative 12x and negative 12x. So we can write this right side as a square and the left side as a square. Alright, so now I have 4x minus 3 squared equals 64. And if we take the square root of both sides, we will get 4x minus 3 equals plus or minus 8. Next, we can add 3 to both sides and divide by 4. Well, 4x equals plus or minus 8 plus 3. And we'll divide everything by 4. We'll have x equals plus or minus 8 plus 3 over 4. Make sure you do the numerator first. There's implied parentheses here. So we would have 11 over 4 as one of our answers, and we would have 5 over negative 5 over 4 as our other answer. So x would equal the set of answers negative 5 fourths and 11 fourths. So I'm going to check this one with Desmos. And our first equation was 16x squared minus 424x plus 9. And the other side of the equation was 64. So f of x equals 64. Okay, and so I need to look up at 64. I have that point there, negative 1.25. That sounds like 5 fourths, and 2 3/4. Okay, so heading back to our notes. Now, it's not always going to work out all that nicely like it did in our review. Sometimes we're going to have to engineer the question to work out for us, and that engineering process is called completing the square. And we can use it to find the vertex and to solve an equation for x values. So in this one, we have just a trinomial, x squared plus 16x plus 12. And what we're going to do is we're going to ignore the 12. We're just going to stick it on the end and not think about it. And what we want to do is we want to set this trinomial up so that it is a perfect square. And it's a little redundant, isn't it? A square that has two side lengths that are exactly the same. So we'll have the x and the x term for our x squared. That's pretty normal. And you want to think about this middle term. We need to add to make 16. So that's 8 and 8. And it was negative 16, so it's negative 8 and negative 8. And so we would have our x squared term. We just created our 16, and this number here was the number that wasn't a part of our equation at all, 64. And so what we can do is we can add it in and we can take it away. And that has the effect of adding 0 plus 64 minus 64. A lot of folks don't draw this box. They just memorize a formula in order to figure that number out that gets added and subtracted. If it works for you, all you do is you take the middle term, you divide it by 2, and you square it to complete the square. These terms over here are just holding on to all the things we're ignoring. So we'll keep that 64 there. And then what is negative 64 and 12? Okay, so we have negative 52 on the end. Now our square is the negative 8. You can see it with my visual over there, x minus 8 squared. And we'll have our final term, 52. So the vertex, remember our last unit on vertex form, is at the point 8. Remember to switch that sign. If it was negative, it's now positive. And negative 52. That is worth us looking at and seeing if we're right. And then we'll sketch it off to the side. And it just says sketch, so we don't have to do a terribly great job at this. So at negative 52, lovely scale, I know, and positive 8, we would have a vertex. Because a term, it's 1, and we will be heading up this way. Where are we heading with this? Oh, more questions about that graph. Where was the y-intercept? The standard form was that first equation they gave us. So the y-intercept is just that 12 on the end. So maybe we can add that to my graph. Y-intercept at 0, 12. Domain and range. Domain, because its parabola is from negative infinity to infinity. The range is, using that vertex form, we'll start at negative 52. And we'll go up to infinity. X-intercepts. Well, let's solve the last equation that we set up for 0. So we'll have 0 equals x minus 8 squared minus 52. So let's add 52 to both sides. And now the square root of both sides. And we'll need to add 8. So right now what we have is x equals 8 plus or minus the square root of 52. Now, you might need to simplify the square root of 52 to figure out if there's any squares hiding inside of it. So make a factor tree and think about what goes into 52. So 2 times 26 and 2 times 13. So that means that 52 was made out of 2 squared and 13. So I really have the square root of 2 squared times 13. 2 can come out, 8 plus or minus that 2 coming out, so 2 square root of 13 equals x. Okay, let's look at that graph and see if we're right, and let's figure out also what 2 plus or minus the square root of 13 is. So going back to Desmos, okay, so we've got that point there, and I said was 8 plus 2 square root of 13. That's 8 plus 2 square root of 13. Alright, so they think that one of the x-intercepts is at 15.2. Oh, looks good. Okay, and then this other one, okay, it was 8 minus 2 square root of 13. Yeah, looks good. Alright, we did it. That seems like a good place to stop.